Inheritance is where object-oriented systems allow for the sharing of the implementation of operations. Consider the classes and their respective operations shown in the figures. A class, or several classes, are allowed to inherit from a superclass. Domain, analysis, and design are the three modeling perspectives that will guide us from a real-world situation to a final software product to address the real-world situation. In terms of object-oriented development, domain modeling corresponds to identifying the important objects in the situation and building models in terms of these objects and their interactions. Its purpose is to get a better understanding of the domain. This can be done as part of the elicitation of requirements, or even when the requirements have been gathered, but it is important, from a developer's point of view, to understand the business situation that those requirements address. In analysis, we use this term. For the specification modeling activities, we assume that software system is needed to address a situation. Here, we model software elements used in a software solution to the problem but avoid too many implementation details. Object-oriented analysis models are built in terms of the software representation of the real-world objects. The main emphasis is on the services provided by the software solution and not on how these services are provided. Design modeling describes the software system, the allocation of responsibilities, and the internal sequencing and control flow. In object terms, a design model represents the software classes and objects, and the messages exchanged between them, and in which order. The functionality of the entire system is distributed among the classes. Reuse is the process of building new software from existing software assets, rather than starting from scratch. Reuse is an important factor in building flexible products that can be changed quickly in response to changes in requirements. Encapsulation encourages better designs that can be reused in a more reliable way, as there is exact knowledge of which operations access which data. It restricts the assumptions made of an object to a well-defined protocol. Inheritance allows a developer to reuse a class whose behavior provides some of the behavior required of the new class, so that only the different parts need to be designed. A framework is a set of classes with well-defined interactions which are designed to solve specific problems. Frameworks are usually developed for a specific domain of application, say, financial management or document preparation. They go some way towards a complete solution, but require some degree of customization, usually through the creation of subclasses within the framework or by overriding operations. Compliance suggests a framework defines a subsystem or mechanism that is customizable. The subsystem design is encapsulated by a set of classes, though the implementation may only be partially defined. One commonly encountered framework is called J2EE. It is a large collection of Java technologies and components that can be used to produce a wide variety of distributed information systems. J2EE has proved very successful and has become one of the most widely used frameworks for the development of client-server applications. A pattern is a general solution to problem. It is the result of abstracting what is common practice and solving a set of similar problems. The patterns movement looked at ways of building on the collective experience of solving frequent problems. Design patterns capture such solutions in a way that can be applied generally. Moreover, by cataloging problems and their solutions, patterns are a means to transfer expertise from the experienced to the novice software developer. Patterns from the literature have many different styles and serve many different purposes. Process patterns describe rules that can be followed when software systems are built. Analysis pattern indicates solution to deal with complexity in models by separating two types: a knowledge mode and an operational model. A design pattern is a set of classes and objects that solves a general design problem and needs to be customized for each specific context. From a developer's viewpoint, case tools provide support for modeling aspects of the system using a variety of notations and techniques, from diagrams to mathematics and text, producing prototype code, and even verifying the correctness of the system design. They also automate the sometimes tedious process of writing system documentation and keeping it up to date. This is useful both for communication within a development team and for project management and decision tracking. Importantly, they improve the quality of the development processes by supporting and to a large extent enforcing a standard methodology and sound design principles. Despite these potential benefits, there are often obstacles to their adoption. The introduction of a case tool within an organization comes at a high cost. An upfront investment is required to acquire the technology and to train personnel accordingly, while the benefits of using the tool manifest themselves only in the long term. Case tools are only effective if standard methodologies and processes are adopted across the organization. The definition of standard procedures and practices also has to be established at the beginning. Most tools support modeling, while hardly any provide facilities for communication between customers and developers. You may wish to attempt the following learning activities. Their possible solutions are provided at the top of the Player tab. Thank you. This unit has introduced the main concepts used in this course and has given an overview of software development with an object-oriented approach and has discussed some of the issues that are relevant to developing software that can be reused.